Good day, viewers. My name is Bakel, and I'm the tutor for the Robotics Core workshop. And I'm here to give you an overview of what we'll be doing in the workshop, as well as a brief introduction into robotics. But this time, we'll be doing it the practical way. As we all know, robotics is the application of different fields such as electrical engineering, mechanical, mechatronics, computer science, AI, and ML, control engineering, as well as software development. So we take knowledge from each of all these fields in order to build a machine that can carry out tasks for us with little to no human intervention. Now, the practical approach we're going to be taking is inspection of underwater structures. Do you remember there was a point last year or a couple of years back where the underwater cables connecting Nigeria to the internet were damaged? So things like this can be avoided if we can supervise underwater structures, from cables to rigs to other kind of structures we see under the water. And inspecting these structures are quite difficult for humans to do. So let's build a robot that can do that. First of all, we need to understand the task. Our task is to be able to go under the water, look for cracks, see the cracks or damages or little tears, and be able to identify that this is the crack, this is where it is, and this is what it is, and send that detail back to the human at the surface. So for this task, we will need a couple of sensors, actuators, and computing power. Now, for the first task, we would love to be able to see the crack, and that way we're going to use a camera as the sensor. The camera sees the crack. Now, the camera doesn't understand there is a crack. What the camera do, it just takes in videos and it's going to send it to another component that will be able to identify the crack. That component is the onboard computer or a companion computer. Now, this is just like your PC and every other computer that you can run a machine learning model or an AI model on. This is where the machine learning and the AI comes in, because this takes in videos, and then we have a machine learning model that has been trained on cracks under the water, what the cracks looks like. So this would be the one to interpret the video and say, okay, there is a crack. Now, we've spotted a crack. We want to be able to move towards the crack so that we can get a steady position to take the pictures and take whatever data we need. That's where this comes in. This is a propeller. Now we're under the water, so our means of motion would not be land, would not be wheels like we're on land. So this sees the crack, this interprets it and sends signal to this. Usually we have like 6 to 8 of them, but this is just for example. And then this will navigate towards the crack. And then once we get there, we look at the crack and we take our data. This is how it is on a basic level. Now, we might want to go deep. We are underwater, so we have to find a way to put all this into a case so water doesn't destroy it. This is our watertight compartment. This is the front. The camera would go in here. And here, we have everything to hold the electrical or the electronics and things like that. So everything that will be damaged by water will fit into this rack and will be sealed here. The rest of the things are other mechanical components that we need for the operation. This is the frame of the robot. So at some point, we're going to like cover up this. This is a marvel of mechatronics. This is called a pix hawk, and this is used as a bridge between the CPU and the propellers or other actuators. In a more complex topic, this translates higher code into lower level signals or commands for actuators such as a propeller and things like that. We might also want to be able to control the robots. I mean, you would want to take the robots down into the area you want it to inspect. This is where we use this. These are this is a logic tech pad. This is usually the standard in the industry. Or if you want to be a bit more tush, you can use a PS5 pad. Another problem we might face is under the water, it's a bit dark. So we have a torch, a very bright torch. You can see how we've combined different components from different fields. We have the mechanical components, we have the electrical components, we have the mechatronics, that's the sensors, we have the AI, this, and then software development, because somehow we would have to write a lot of logic, a lot of software, and a lot of things. So this basically is an overview or an introduction to how things work and how things come together in robotics. For obvious reasons, these equipment will not be available for the workshop. Everything here is a little bit over 8 million, about 5,000 euros thereabouts. So it's not practical to have this for everybody. I have this because I won some of them from a competition in Greece, a robotics competition in Greece. This was some of the prizes I got. At the same time, I purchased some of them for my experiments and things like that. For the workshop, we're going to do what's called software in the loop simulation. Now, before you go around spending thousands of euros to buy things like this, you need to run a simulation. You need to see it in your computer. Every single component that is here, I have it simulated on my PC. So I don't just go around buying things. I mean, you could buy something that is not compatible, and at times an onboard computer can cost around $500 to like $1,000. So you won't want to buy something you don't need. So the first step is to simulate it, to design it, to have it run in a software in the loop simulation. So you find out, oh, I don't need this part, I need this part, this is what I need, and this was what will suit my project. So before I got all of these, I actually had it simulated. And this is what we will do in the workshop. We're going to have simulations of all these. It's going to be as though it's in the real life scenario, but I know it's not in the real life scenario yet because we can't afford all this at the point. So at the end of the workshop, we'll be able to think like robotics engineers, just the same way I have thought of a problem and I've brought out things that's going to help us solve the problem. So thank you very much, and I hope to see you there.